Subtraction principle. When solving a linear equation to find a solution, our goal is to have the variable alone on one side of the equal sign. And the subtraction principle is to move a positive term. We do the opposite and subtract. However, anything we do to one side of the equal sign, we must do to the other side as well. And it's very important to show all your work. So let's go look at an example. Example 1. What is the resistance of the second resistor if the total resistance is 10 ohms and the first resistor is 6 ohms? Use the equation below to help us solve. So here we have our equation, and we're going to go ahead and rewrite it just so it's easier to see. Now, the first step is to get the variable alone. So how we do this is we're going to subtract on the right hand side the 6. So we have positive 6 minus 6, which is equal to now 0. And then we can just bring down the x. We have our equal sign, and then we have to do whatever we do to one side, we have to do to the other. So we'll subtract 6 on the left hand side, and we get 10 minus 6, which is equal to 4. So x is equal to 4 ohms. So let's go ahead and look at another example. Example 2. What is the resistance of the second resistor if the total resistance is 85 ohms and the first resistor is 45 ohms? Use the equation below to help us solve. So now we have n plus 45 is equal to 85. What we need to do is get our variable all by itself. So how we do this is we're going to go ahead and subtract 45 to both sides, because whatever we do to one side, we do to the other. So 45 minus 45 just gives us 0. So we have n plus 0, which is equal to now 85 minus 45. So 5 minus 5 is 0. 8 minus 4 is 4. Here's our calculator. We can confirm that we did it right. So we go 85 minus 45, which is equal to 40. So n is equal to 40 ohms. Let's do another example. A voltage divider is connected across the output of a power supply and has a total voltage of 12.4 volts. The voltage drop of 1 is 6.7 volts. Find the voltage drop of the second one. We're going to use the equation below. So here we have 6.7 plus n, which is equal to 12.4. So what we need to do is get n by itself. So we're going to subtract 6.7 to both sides, as this is positive, and to do the opposite is to subtract. So this becomes just 0 plus n, which is equal to, let's get our calculators out, 12.4 minus 6.7, which is equal to 5.7. And this is in volts. Now, we can go ahead and verify that we did this right. So what we can do is substitute this n of 5.7 into our equation. So we would have 6.7 plus 5.7, which is equal to 12.4 is what we're hoping. So we'll get our calculators out, and we're going to add the first two terms. So we have 6.7 plus 5.7, which is equal to 12.4. So we know we did this right, as 12.4 is equal to 12.4. So this equal sign is true, as the variable of n is 5.7. So we can write a check to show that we did this right. So let's go look at another example. Example 4. Two coils are connected in a series. The total inductance is 1,700 millihenries. One coil is 800 millihenries. Find the inductance of the second coil. Use the equation below. So here we have our 800 plus L2, which is L just represents inductance when you see that. And it has a subscript of 2 to show that's a second coil, which is equal to the total inductance of 1,700. So what we need to do is just to get L2 by itself is subtract 800 to both sides. When we do this, we get 800 minus 800, which is 0, plus L2, which is equal to 1,700 minus 800. So let's get our calculators out. And we get 900. So L2 is equal to 900 millihenries. So that's our second coil.